We are discussing about discrete time convolution. Coming to the introduction, convolution is used to calculate the output of an LTI system when the input to the LTI system and the impulse response of the LTI system is provided. I will first give you the idea of discrete time convolution and then we will solve one example. We are having one discrete time LTI system with us and the input to this LTI system is x of n and impulse response of this LTI system is h of n and the output of this LTI system is y of n. We need to calculate y of n by discrete time convolution. We get y of n by simply convoluting x of n with h of n as shown in the given equation. First, we change the variables of both the signals to a duplicate variable k. Then we will perform time reversal operation and then we will perform time shifting operation as shown in the given equation. We perform multiplication of x of k and h of n minus k. So this is what we do in convolution operations when we are dealing with the discrete time LTI system and discrete time signals. Let us discuss an example now. In the following question, we need to calculate y of n. The given input and impulse response both are unit step sequence. Therefore, y of n will be equals to convolution of u of n with u of n. So y of n will be written as shown. Let's see the solution now. First, we had plotted both the signals as shown and then by replacing the variable n with a duplicate variable k, we get the plot as shown. By replacing variable n by k, there is no effect on plot of the signal. Now we will leave input signal as it is and we will perform time reversal operations on the impulse response. In time reversal, we simply flip the signal waveform and about the y-axis and we will have the plot as shown. Upon this new signal, we will perform the time shifting operations. So let's perform the next operation, that is the time shifting operation by an integer n. You will see that the waveform is shifted to left by n and the signal you see as u of n minus k. Now we have uk and u of n minus k. Now let's analyze what will happen when we multiply u of k and u of n minus k depending on the value of n. Let's take case 1 when n is less than 0. For example, when k equal to 0, the green plot is having the value equals to 1 but the pink plot is 0. So 1 multiplied with 0 equals to 0. Similarly, for all values of k, we get 0 when n is less than 0. Therefore, the output of y of n equals to 0 when n is less than 0. Now we will consider the next possibility when n is greater than or equal to 0. Let's take one example, that is when n equal to 2, the plot of u of n minus k will now shifts, but u of k will remain same. Initially, you can see that when n is less than 0, when k equal to 0, u of n minus k equal to 0, but now it is 1. Similarly, when k equals to 1, u of n minus k equal to 1. Similarly, for k equal to 2 also, u of n minus k equal to 1. For other values of k greater than 2, u of n minus k is still 0. Let's calculate u of k multiplied with u of n minus k for the different values of k. And we will first consider the negative case, which is k less than 0. For example, when k is minus 2, u of k equal to 0 and u of n minus k equal to 1. So 1 multiplied with 0, we get 0. For all the values of k which are negative, we are going to get 0. Now coming to the positive side, when k equal to 0, 1 multiplied with 1 equals to 1. Similarly, for k equal to 1 and k equal to 2 also, we get 1. When k equals to 3, u of k equals to 1, but u of n minus k equal to 0. So 1 multiplied with 0, we get 0 and it will remain 0 up to k equals to infinity. So we get y of n equals to 0 up plus 0 plus 0 plus 1 plus 1 plus 1 up to so on plus 0 equals to 3. And we know u of n equals to 0 when n less than 0 and 1 when n greater than or equal to 0. Let's multiply n plus 1 to u of n. We get 0 when n less than 0, and n plus 1 when n greater than or equal to 0. By comparing, we can write that as y of n equal to n plus 1 into u of n, which can be written as y of n equals to n plus 1 into x of n, as x of n equals to u of n. Now we will see how to perform discrete time convolution using a more simple method known as tabular method. The statement is, if a signal having m samples and convoluted with n samples, you are going to get m plus n minus 1 samples. In the given example, we are having two discrete time signals, x of n which is equals to 1, 2, 3 and 4, and h of n which is equals to 1, 1, minus 1 and 1. Here we have 4 samples convoluted with 4 samples, so we will get 4 plus 4 minus 1, that is 7 samples at the end of convolution. We need to multiply crosswise as shown. We will get y of n by considering the diagonal sum, that is, we got y of n equals to 1, 3, 4, 6, 3, minus 1 and 4. Totally we got 7 samples, that is, we got m plus n minus 1 samples. Thank you.